Okay, example 10. So the next section, which is section 7.4, solving trig equations. I'm going to start with example 10. We're going to solve this equation to 1 decimal places, and theta is going to be between 0 and 360. So the first thing we're going to do is notice this is a single theta here, but here the angle is theta minus 30. So we've got no choice but to expand this left hand side. So we're going to use cos A minus B. So that is cos A, cos B, plus sine A, sine B. It's always a good idea to quote this. With our question, A is theta and B is 30 degrees. So what will happen there? You will have cos theta minus 30 is going to be cos theta cos 30 plus sine theta sine 30. This will give me root 3 over 2 multiplied by cos 30 if you put it in front, and this is a half of sine theta. Okay, so let's substitute this into our equation. You will have 4 times root 3 over 2 cos theta plus a half sine theta is equal to 8 root 2 sine theta. I just realized you could have cancelled by 4, but never mind. We'll actually multiply it out and then gather the terms together. So this one multiplied by 4 will give me 2 root 3 cos theta plus 2 sine theta is equal to 8 root 2 sine theta. Let's put all the signs together, because you could see that you've got combination of sine and cos and then sine on the other side. You'll be able to change everything to tan in a minute. So 2 root 3 cos theta can stay on that side, and here we've got 8 root 2 minus 2 lots of sine theta if you put them together. So now we're going to divide by the sine theta by cos theta, and this cos theta by cos theta, so the equation stays as intact. So over here that will become tan, and that cancels. So you've got tan theta is going to be 2 root 3 divided by this. Okay, so theta is going to be tan inverse of 2 root 3 over 8 root 2 minus 2. So I'm going to pop it into the calculator. We are working in degrees. I don't know, actually they've got inclusive ends in the textbook. We are in degrees. So again, tan inverse, and then we're going to pop these into the calculator. So it's 2 root 3 on the top, and then 8 root 2 minus 2. So it's 20.4. Tan, don't need to sketch tan. Tan repeats itself every 180 degrees. So the other one is 200.4 to 1 decimal place. So let's have a go at example 11. 3 cos 2x minus cos x plus 2 is equal to 0, and we're going to find the solutions between 0 and 360. So if you notice here, you've got cos 2x and you've got cos x. So they're different angles. So we need to have within this equation the same angles. So we're going to change cos 2x into cos x's or sine x's. I think we'll go for cos x's, since the one that's remaining is cos x. So using the identity for cos 2x, cos 2x equals 2 cos squared x minus 1. We can replace it into this equation. So 3 lots of 2 cos squared x minus 1 minus cos x plus 2 is 0. Expanded, you've got 6 cos squared x minus 3 minus cos x plus 2 is 0. So you've got 6 cos squared x minus cos x minus 1 is equal to 0. Let's use m equal to cos x, a dummy variable, to solve this quadratic. 6m squared minus m minus 1 is equal to 0. So that should be 3 and 2. We want 3 to be negative, so it's minus, and that will be plus. So m is minus 1/3, or m is a half. But our m is cos x, so that gives me cos x is a half. That's from 0 to 360, cos inverse 60 degrees, so pi over 3. Remember, for cos, for the second solution, we always take it away from 360, which here is 2 pi. So it's going to be 2 pi minus pi over 3. So it's going to be 6 pi over 3. Take away 1 is 5 pi over 3. The second equation is cos x is equal to minus 1/3. So x is cos inverse of minus 1/3. This gives me the first angle 109.5, and the second one we're in degrees here. I do apologize. This should be in 60 degrees and 300. There you go, because that's 360 minus 60. And this one here is going to be 360 minus 109.5, which gives me an answer. Gives us the answer of 250.5 degrees. So let's list our solutions. You've got 60, put them in order of size, 109.5, 250.5, and 300. Question asks you to give the answers to 1 decimal place. No, it didn't. So I guess you could have given the answers to 3 significant figures, and that should be fine as well. Example 11. We're going to solve this equation. So you could see that there is a double angle formula, so the angles are different. You can't do anything with that until the trig functions are of the same angle. It doesn't have to be single, as long as they are the same angle everywhere. So at the moment, you need to change cos 2x into a single axis. Now, you know that there are 3 versions of cos 2x, so I'm just going to remind you. Cos 2x is cos squared x minus sine squared x. You can always use this one and then decide what to do. You've got 2 cos squared x minus 1, and you've got 1 minus 2 sine squared x. Technically speaking, it doesn't matter which one you use, because then once you've substituted, so replace cos 2x with one of these, you will glance at it afterwards, and then you decide, what do I do next? If you want to think ahead, you might want to just save a little bit of work by realizing that this is the bit that you'll be left over after you've replaced that. So it makes sense to use the identity that has cos x in it. So then you will end up with an equation in terms of cos x only. So that's what I'm going to do. So I'm going to replace cos 2x with 2 cos squared x minus 1. And then that becomes an equation from last year. So times that by 3, you've got 6 cos squared x minus 3 minus cos x plus 2 is equal to 0. combining 6 cos squared x minus cos x minus 1 is equal to 0. That becomes a quadratic equation. So if you've got m squared minus m, 6m squared minus m minus 1 equals 0, we will have 3m, 2m. That should work nicely. We want it to be negative 3 to make 3m plus 2m equals to minus m. That's perfect. So m is equal to minus a third, or m is equal to a half. But our m is equal to cos x. That was just dummy variable. So cos x is equal to a half. That gives me the solution. So do cos inverse. You should know when it's equal to a half, but you can check on the calculator. That gives you 60 degrees. And you remember, for cos, you always subtract from 360 for the second angle. So this is going to be 360 minus 60, which gives you 300. Okay. The second one is going to be cos x is equal to minus 1/3. We do cos inverse of minus a third, or cos. If you don't want to use the fraction button, just put minus 1 divided by 3. That means a third. 109.47. So it's 109.5. And remember, if this is 109.7, the other solution is going to be, so 109.5, this is going to be 360 minus 109.5. So it's 360 minus ans. That gives me 250.5 degrees. So to 1 decimal place. So we've got 60. I like to pair them together from depending which equation they come, or you can put them in order of size as well. It's up to you. There you go. These are the solutions. Okay, so we've got next example, which is example 12. In this example, let me just see what the wording is. We are going to solve it. It's an equation. So we are going to, again, you've got 2y and y. That's no good. I can only solve it once you've got a tan y going in the question, or just tan 2y. Clearly, tan 2y is easier to change into tan y than tan y into tan 2y. So tan 2y, so using our tan 2a, it's going to be 2 tan y over 1 minus tan squared y. If you need to use tan a plus b, because you've not memorized tan 2y, that's perfectly fine. All you need to do is quote the formula from the formula booklet, and then let a and b be equal to y. There you go. And then you've got y plus y, which is 2y, and then you have tan y plus tan y, which is going to be 2 tan y, 1 minus tan y times tan y, so tan y times tan y, which is tan squared. So you may want to do that. So let's replace tan 2y with this fraction. So it's 2 times 2 tan y over 1 minus tan squared y multiplied by tan y is equal to 3. Okay, so what I'm going to do here to get rid of fractions, I don't like the fractions, I'm going to multiply it by 1 minus tan squared y, so it will effectively go onto this side. Here we will have 2 over 1 and then tan over y, so you've got 2 times 2 tan y times tan y, so it's going to be 4 tan squared y left on this side. And then you've got 1 times 1 minus tan squared y times 1, so effectively that will go over here. So 3 times 1 minus tan squared y. Okay, so you've got 4 tan squared is equal to 3 minus 3 tan squared. So you've got 7 tan squared y is equal to 3. Let me just make some room over here. Actually, let's do it on a separate piece of paper. So you've got 7 tan squared y gives me tan squared y is equal to 3 over 7. So tan y could be plus or minus square root of 3 over 7. So we need to solve two equations. Y is equal to tan inverse of root 3 over 7 and tan inverse of minus root 3 over 7. So the two possibilities. We are solving in radians between 0 and 2 pi. So let's change our angle unit to radians. And we're going to do tan inverse square root of 3 divided by 7. So that gives me 0.5796. I'll round it to 3 significant figures in a minute. Remember, tan repeats itself every 180, which is pi. So I'll add pi to that. So the second one is 3.7212. Okay, let's do the second solution. So let's go back there. If you can go back, all I need to do is stick a minus here. Okay, so this one gives me, write it down, although it's outside our range. Okay, because we are going to add pi to this. So that gives me 2.56195. And then will be another pi. Okay, so add another, keep on adding pi's till you get all the angles between 0 and 360, which is 2 pi. There you go. So let's jot down the solutions. Let me just double check what is the degree of accuracy they wanted. 3 significant figures, I think. Or 2 decimal places. Okay, 2 decimal places. So the first one is this one. So 0.58 radians. The second one I got is 3.72 radians. Now this one here is outside the range. If you quote it, it's not a problem. They won't deduct any marks, but you definitely need to use it. So 2.56 and 5.70. Perfect. Good. Okay, so right, example 13, you have to prove sine 3a is equal to 3 sine a minus 4 sine cubed a. They give you a hint that you need to write 3a as 2a plus a. So they are advising you to use addition formula. So addition formula is written over here. And what we're going to do, we are going to replace the 2a, the a in the addition formula with 2a. And b will be replaced with a. There you go. So what we're going to get is sine 2a cos a plus cos 2a sine a. Now we want single a's here, so we don't want 2a either with sine or cos, so we're going to replace them. So sine 2a rather, is 2 sine a cos a. So that's 2 sine a cos a, and then followed by another cos a. So we've got no option but to use this one. For the second one, I would advise you to, well, any of them would do, any of the three that you should know, but I think it is advisable to use the one that utilizes sine A, as we want just sine A in our answers. So it's 1 minus 2 sine squared A. So you've got plus 1 minus 2 sine squared A multiplied by sine A. So here what we could do is write cos A times cos A as cos squared A. Okay, and that's good news, because cos squared A, you'll be able to replace it in the next line of working with 1 minus sine squared A. And then expand this to get 1 times sine A, so it's sine A minus 2 sine cubed A. Okay, so let's do 2 sine A, and the replacement for cos squared is 1 minus sine squared A. Add sine A minus 2 sine cubed A. So this is 2 sine A minus 2 sine cubed A. Add sine A minus 2 sine cubed A. So we've got 2 and 1 sine A gives us 3 sine A. And we've got minus 2 and minus 2 sine cubed A, so minus 4 sine cubed A, which is our right hand side. So we've proven the result. Example 13. So we've done part A. We've proven that sine 3A is equal to 3 sine A minus 4 sine cubed A. In part B, we're going to solve the following equation, and we've got to put all the answers in terms of pi. So we're looking for exact solutions. So we are going to use this result. So what you could do, you can just see what happens, because I notice in my equation there's 16 sine cubed. So in the identity there is 4 sine cubed, well it's minus 4 sine cubed. So if I multiply it by 4, everything, I'll have 4 sine 3A is equal to 12 sine A minus 16 sine cubed A. And then have a glance at the equation. We've got 12 sine A minus 16 sine cubed A. That can be replaced by 4 sine 3A. In the equation, I've got 16 sine cubed A minus 12, so the opposite. So this could be replaced by minus 4 sine 3A. So I'm going to do that. That underlying part can be replaced with minus 4 sine 3A minus 2 root 3 is equal to 0. So 4 sine 3A is going to be equal to minus 2 root 3, giving me sine 3A to be, if you divide it by 4, minus root 3 over 2. So that's a nice answer. Now, since we are solving for theta, my mistake is to use the A in the solution. So what I'm going to do is go back and replace these A's with theta, actually. That's what I'll do. Otherwise, you could just say let theta be equal to A, and you can then get A as the answer, and then in the final line write the answer in terms of theta. Okay, so we are solving for 3 theta, so that means we need to go up to 6 pi. There you go. So we are looking for, there's 2 solutions in up to 2 pi, so there will be 6 solutions. So 3 theta is equal to sine inverse of minus root 3 over 2. And then have a look on the calculator. The calculator was going to give you negative acute angle, so it's minus 60 degrees, which is minus pi over 3. But obviously we're going to use this our principal angle from which we are going to derive all the other solutions. So if this is my sine graph, this is minus pi over 3. So the solution within up to 2 pi, that's all I need to do, is find the two solutions up to 2 pi and then add multiples of 360, which is 2 pi, to these solutions. So this one here is 2 pi minus pi over 3. So that's going to be 6 pi over 3 minus pi. So it's 5 pi over 3. Do it on the calculator. And this one here is pi plus pi over 3. That gives me 4 pi over 3. So the two angles within the range are 4 pi over 3 and 5 pi over 3. I'm going to add pi to these to get the next pair, which would be in the next period. So we are going to add pi, so that will give me 6 add 4 is 10 pi over 3, and this one is going to be 11 pi over 3, and then add 2 pi. I did say I added 2 pi, but wrote pi. Adding 2 pi to that, so 6 pi over 3 gives me 16 pi over 3 and 17 pi over 3. So you've got those 6 solutions. However, this is what 3 theta is equal to. So we are going to divide everything by 3 and then jot down the solution. So theta is equal, if you divide 4 pi by 3, you get 4 pi. 4 pi over 3 by 3 is 4 pi over 9. 5 pi over 9. 10 pi over 9. 11 pi over 9. 16 pi over 9. And 17 pi over 9. Okay, so this will take us to exercise 7D. There you go.